Hello and welcome to part 3 of our chapter 3-4 class problems. So we're going to get right into number 11. Assume the following table of observations in a dataset represents a sample of fasting glucose levels separated by diabetes status. So here we have our table with patients, your fasting glucose, and your diabetes status, and then it also splits over into another side for a patient fasting glucose diabetes status. Since our patients are in A, B, C, D order, let's number them so we know how many patients we're actually dealing with. Oh, if I could actually number correctly. 2, 3, 4, 5, 6, 7, 8. So we know our n is equal to 8. Let's just write that down so we know. Alright, next thing we're going to do is we're going to calculate the mean, median, 5-point summary for a data set here. So going a little quicker, so we're going to calculate the mean for a data set. So we're looking at the fasting glucose levels here, and we're going to add them all up and get our sum, and then divide our sum by 8, and you're going to get your x bar. Like I said, I'm going to go a little quicker with this kind of stuff because we've already done averages in the previous video. You're going to get a mean of 119.375. The next thing we need to do is do our median and 5-point summary. So for this, we're going to want to rearrange our data set in an order. So I'm going to put the order down here, 79, 81, 119, 121, 128, 131, 147, and 149. Great, we know there's n, so it's an even number, so we're going to have to find the middle between the 2 points for our median, and when we do that, our median is going to be between 121 and 128, add them up, divide by 2, and you get a median of 124.5, and you'll see that in our 5-point summary. So when we do our 5-point summary, right, we're going to have Q1, which is going to be our lowest value, which is going to be 79. Our Q1, which is going to be our first quartile value, which is going to equal 100. Q2, which is going to be your median, it's going to be 124.5. Q3, it's going to equal 139, and Q4 is going to equal 149. So in case you're wondering where we get these values, so we have our data set here. We add 121 plus 128 and divide by 2, you'll get 124.5. And when we have our data set, since we're dealing with an even number here, our median value is going to be here. So we're actually going to separate our two data sets kind of in half. And when we find our middle value for our Q1, you're going to find, right, so we have, think of this as like a data set of 4. And we want to try to find the middle value between this data set. So it's going to be between 81 and 119. You would add those up and divide by 2, and that's where you get 100. So our Q1 is the middle value between these points here. Same thing on this side. 131 plus 137 divided by 2 is going to give you your Q3, right? It's the middle of those quartiles. So here's our 5-point summary. Our median is our Q2. And the next thing you want to know is our IQR. Well, our IQR is equal to your Q3 minus your Q1. So if you take 139 and minus 100, it's going to equal 39. So our IQR is 39. Next thing you want to know, are there any outliers? In order to determine there's outliers, you have to first put in our fence for our lower, and then our fence for our upper formulas. Our lower fence formula is going to be your Q1 minus 1.5 times your IQR. Your upper is going to be your Q3 plus 1.5 times your IQR. Put our values in for these. So you're going to have 100 minus 1.5 times 39. And then this one's going to be 139 plus 1.5 times 39. Now remember, if you put this all in a calculator like this and don't have parentheses, and really, if you don't have the parentheses in the correct area, you're going to get a wrong value. So remember, you have to follow your orders of operations. You always multiply before you add or subtract. When you do this, you can get 41.5 as your lower, and your upper is 197.5. So are there any outliers? Well, is there any values less than 41.5? No, our lowest value is 79. Are any values above 197.5? No, our highest is 149, so there are no outliers. For purpose of time, I've kind of created a box plot over here to the side. So you can see here would be your box plot. And what you do is these are just, it's your 5-point summary, just kind of in this box form. So this would be your Q0, which is going to be 79. This is 100. This is your 124.5. This is 139, and this is your 149. This is the best I could do for hand drawing it, but that's what your box plot summary states. It just tells you what your 5-point summary is. All right, so moving on to number 12. So number 12 here, we might take the whole time for the rest of the video doing this one because it's going to be going over standard deviation, and standard deviation is one of the core things that we will be going over in the class. And without standard deviation, we don't really do anything else when it comes to the other statistical testing. So knowing what standard deviation is, knowing when you go plus or minus 1 standard deviations out from the mean, and we have our 68, 95, 99.7 rule. Taking all this into account, it's all around standard deviation. So understanding how standard deviation works is crucial. So number 12 here is researchers are interested in monitoring the CD4 cell counts in a group of HIV positive patients treated with new antiviral medication. Suppose the following table represents the CD4 counts for a particular patient at various follow-up days in the study. Calculate the mean, median, and standard deviation of CD4 for the patient under the investigation. So here's our data set count and study of days, right? And we first want to know how many different points do we have in the study. So how many times did they do their CD4 count measurement? And the answer is 7. They did it 7 times. First thing we want to know is what is our standard deviation formula. So our standard deviation formula is equal to, so standard deviation is equal to square root of 1 over n minus 1 times the sum of x sub I minus x bar squared. And we're going to go through all these steps here in a second, but the first thing we have to do is we have to get an average. So we have to calculate our x bar. Our x bar in this problem is the sum of all the CD4 counts divided by 7. You get your x bar. X bar is going to equal 416.2857. So now we have our sum. So the first thing we're going to do, or we have our x bar. So the first thing we got to do is we got to do our x sub I minus x bar. Your x sub I is the individual data point that you're looking at, right? So we've calculated the average. Now we're going to calculate the deviations from the average and square them. Because if you didn't square them, then we would just, deviations always sum to 0. So you take your data point of 438, you're going to subtract it from 416.2857. It's going to give a value of 21.7143. You're going to square that, right, because that's what we're doing here. We're squaring it. And when you square 21.743, you get 471.5108. Now we have to do this for all of our data point sets. So we need to do that for 421, 419, 418, 411, 409, and for 398. And we have to subtract them all from 416.2857. So give me a second to write all this out. Yes, standard deviation by hand does take a little bit of time. But like I said, it's the foundation of what we're going to be going off of here. And we will be using this throughout the entire semester. So better to get learn how to do it now and and know how to do it for the future. So we take your x sub I minus your x bar, and that's going to give you a deviation. So for this one, 4, 17, 4, 3, and then we're going to square them. And that's going to equal 22.2246. And you're going to do that for every one of these values going down. .9, 388, 5.2857, 27.9386. Like I said, you're going to do it for every one of these values. Take your x sub I minus your x bar. You're going to take this value and you're squaring them as per the formula. And this equals 334.3668. Alright, so now we've done x sub I over minus x bar squared. Now we have sigma, which is sum. So we're going to add all these up. When you add up all these values, you get 119.4284. And then once we've added them all up, we're going to take 1 over n minus 1. So we're going to take this total and subtract it from our n minus 1. Well, what's our n? N is 7. So 7 minus 1 equals 6. So we're going to take, I'll rewrite this, 119.4284, and we're going to divide it by 6. When we get that, we're going to get 153.2380. Now this value right here, once we divide this out, is actually called the variance. You'll notate it as s squared. It's not the best squared. Notate it as s squared. And then if we want to go from s squared to s, we would just take the square root, right? And that's what we do here. We take the square root and we get our standard deviation. So we take the square root of 153.2380, and then we get our standard deviation is equal to 12.3789. So one thing always to keep in mind here is before we take the square root, that is called the variance. That's s squared. To go to s squared to s, you take the square root, which is what we do in the formula, and you get your standard deviation. So kind of just overviewing it, our standard deviation is gonna tell us how far from the mean the data points lie, as an average. And so in order to determine this, we take our data point, subtract it from our x bar, and that's our deviation. If you were just to add up all your deviations, you're going to get, it's going to equal 0. In order to try to find the full average, plus and minus the average, we square them. And this is going to give us a positive value here. And we're going to do this, when we square, this is the sum of squares. When we square it, then we divide by the degrees of freedom of n minus 1. Telling us how much variance there is, how many variables there are to move around. And that would be our n minus 1 is 6 here. And then divide that out, and that gives you your variance. Just take the square root of the variance to get your standard deviation. And that's how you get standard deviation. So we've calculated the mean. The median, median we didn't do. Median, you just put these values in order. When you put them in order, your median value is going to equal 418. And standard deviation. I more or less wanted to show you the steps for standard deviation. Okay, not exactly sure how much time is left, but I'm going to just pause the video there so you always have a point to come back and look at standard deviation, and I'll pick up the last problems